Welcome to this new series from game developers geared toward a new 3D game engine, which version 1.0 has just been released, FLAX Game Engine. In this video, we are starting to implement some basic player movement and jumping to evaluate the engine workflow and stability. We want also to check on the interoperability between the different scripting mechanisms theoretically supported by the engine, C#, C++, and visual scripting. So, we have a lot of things to do. Let's jump into the actual tutorial. We have started from a default scene template with a basic cube, floor, camera, and lighting. Except for the camera and light, let's delete everything as we want to start our own world. Now, from the toolbox on the right pane, select the option Basic Models, and drag a cube into the scene view. From the physics, drag a box collider and released over the cube already created. We want it as a child of the cube, as to be manipulated easily when modifying any option from the cube. Now, let's change the name of the cube to Ground and the box collider to Ground Collider. These will be our world ground. Go to the inspector properties, and scale the ground object to 40 in X and 40 in Z. We won't need so much space today, but we will certainly need it in future videos. We can see that the texture has been stretched and it is not looking good. So in the inspector for the ground actor or game object, go to the material option, and click in the small arrow pointing down. It will show you some of the instance materials available in the FLAX project to be used. In FLAX, what we call shader in Unity, is a material. And what we call material, is called instanced material. Choose the white material or the material that may suits your needs the best. As soon as we change it, we can see that our ground is looking much better. Now, let's create our player. From the toolbox, choose a new cube and drag it on the scene view. Rename it Player OBJ or any other name you may like. From the physics category, drag a rigid body into the scene view and rename it as Player. Drag the player OBJ to be a child of the rigid body. FLAX is not like Unity or Unreal, but closer to Godot in what is related to the paradigm game object and game component. Game objects are called actors, and you cannot add elements like a rigid body to an actor, but rather start with the specific actor for the behavior you want. So, in this case, we want to move the player with a rigid body, then the root actor must be a rigid body. Let's drag a box collider also to the player, as to allow it to collide with the world. Now, let's take care of the visuals of the player. We don't want it to be white too, it would be too difficult to see against a white world. So, select the player OBJ and, as we have done for the ground object, under the material option, click the arrow pointing down, and in this case select the solid color material. This will allow us to set a color for our player. If you double-click on the icon of the instance material, you will see a new window that allows you to change all the properties of your material, and even the way it is built using visual scripting. In our case, we just want to change the color, so go down the list of options to the color field and choose the color that you prefer. In our case, we went for a bright red. Time to create our first C# script. FLAX is not as flexible as Unity, but in this case is closer to Unreal, where everything is very tied to the structure of the project's folders hierarchy. So, to create a new script, you must go specifically to the source folder. You will that you have already some C# files in it, but it is better not to create any of the project scripts there, as the top folder is used by FLAX to keep compilation references for the project. So, let's go into the game folder, and right-click in the content view, and choose from the pop-up menu the option New C# script. You can see that we have both the C# and C++ options here. Don't choose for now the second one, as we will specifically address it at the end of the video. Name it player, or any name that could match better your needs. Double-click to edit. Depending on your configuration and on the default options that you have set for your project, a different editor will open. You can watch the previous video to know more. C# scripts in FLAX are very similar to Unity or Godot. A lot of functions will have very similar syntaxes, but others will be very different. You can see that most of the pre-existing functions are very similar to the ones that we would find on Unity, but we can also check on the first difference. The class that we have created is built on top of the script class and not on mono behavior. One of the first difficulties that we have found is that, although we know that there are no components in FLAX and that you have to use the alternative function getChild or getScript, we were not able to access something as basic as the rigid body script. It must be something more related to the fact that we are not yet experts. Enough talk. Let's script. If we are going to move the object using the rigid body function, then we need to access it from the script. So, let's define a public variable to get its reference. You can see that it is exactly how we would have done it in Unity. Let's create a variable force jump to hold later on the amount of force to be added up to the rigid body and set it in motion and jumping. Let's initialize it with 1000. Under the on update, let's create a new vector3 movement that will hold the direction of the player movement. Let's initialize its value to a new vector where the x-coordinates will be taken from the input horizontal, and the z-coordinates from the input vertical. If you arrived at this moment in the video, you could almost think that you are watching a Unity tutorial video, as it is almost the same. Once that you have the direction of the movement, let's normalize it. And if it is different from 0, let's add a force to the rigid body with the function add force based on movement multiplied by the force factor force jump, and by setting how the force should be applied. In our case we have to choose acceleration. Let's return to FLAX and continue the process. On the bottom right bar, you can see the compilation process of the new script, and in the output log the warnings and errors that you get. The errors will be displayed in a red color, which against the black background makes it very difficult to read it, but always check if you have any read line, because if not the script will not run. To add the script to the actor or game object, you need to drag it specifically to the area in the inspector where it says add script, or on top of the object in the hierarchy. Be careful, because in FLAX, as you can see in the video, you can add more than once the same script to the object. As soon as the script is added, the inspector will show it and its public parameters. So, let's drag the player in it to get the reference to the rigid body. Since we are basing our example on one of the default templates, the camera has a free camera script that we need to delete to be able to focus on our player. Once done, run the game by clicking on the play button in the center of the top bar. Let's reorganize the editor views to be able to have the game and scene view at the same time. Be careful, when running the game, to have always the game view selected or the controls will not be captured by the game. You can see that when the game view is selected and active, there is a blue bar on the top of the view. If we try to move the object, we cannot see any movement. Although, If you look closely at the transform properties in the inspector, you can see that the numbers are slightly changing. Let's juice up the force to 5000. And now we have a player that is moving across the screen in a very chaotic way. This is another of the big differences between Unity and Unreal. We have found that to make things happen, and specifically, in this case with the force, we need to have higher values. You can play around with the force jump value. In our case, we ended up setting it at 2000. To fix the movement problems, just like we can do in Unity, let's go the constraints options of the rigid body and lock the rotation on X and Z. And now, the movement is more fluid, but very affected by the friction. This another of the characteristics of the engine. A lot of the physics properties are much more emphasized than in the other engines. To fix it, let's select the player collider, and under the collider properties, you will see a slot for a physics material. We cannot create it from the inspector. We have to go to the content browser under the content folder. We will have here several predefined folders, so let's create a new physics material by right-clicking on the folder content. Rename it to player and double-click to edit. Set the friction to 0. And lower down the restitution to a lower value. This is similar to the bouncing option in Unity Physics Materials. Save and drag to the Collider Physics Material slot. If we run the game, we can see that the movement is now much smoother. Let's now create the jump, and to fulfill our promise of including visual scripts, and their interoperability with the other C# and C++ scripting, let's use a visual script to implement it. To create a new visual script, you need to go to the content folder, and then right-click and choose under the new option, the visual script. It will create a new file that we can rename, in our case to jump. Double-click it, and the visual scripting editor will open. On the right, you can see the different options available, like the base class, set to script, and some special attributes associated with the type of class we want to create. Under it, you have the add functions and add parameters buttons. We will not use functions in this example, but it allows basically to create some functions to hold repetitive code. In add parameters, it is where you define the parameters that we can pass into the script, and that will appear in the inspector. Let's create first a parameter of type rigid body to access its class from the visual script. In the central view, it is where you define all the visual nodes that will implement the code. So, let's create the first node. If we want to jump, we need to check on every frame if you have pressed the jump button. So right-click on the editor and in the node selection search box, type on update. As soon as you choose it from the options, a new node will be created. We also need to check if the jump key has been pressed, in our case the spacebar. So right-click again, and choose the function getKeyDown from the options. To join them, let's create a new node of type if, and let's link the three nodes by creating links between the different visual elements. So, from onUpdate, Link the play or execution icon represented by a triangle to the one in the if node. In the key field, choose the space bar. From the Get Key Down node, let's link the return field to the condition field in the if node. You can also start to see that usually the fields that need to be joined between nodes have either the same icons or the same colors. If this condition is true, then we need to add to the rigid body a force. To access the rigid body, let's drag the parameter that we have previously defined into the editor view. And a new node will be created. Let's create now the action itself of adding the force. So, create a new node and choose the Add Force option. Link the if and get parameter options into the new node. To control the force that will be applied, we could either enter the values manually, which would be then complex to edit, or to create a new vector3 parameter to receive the force from the inspector. Once done, drag it to the editor view and link it into the Add Force node under the Force parameter. Just to be sure that everything is running correctly, we will also debug log a message jumping. Save and exit the Visual Script editor. A visual script is just like a regular script, just edited visually. This means that you have to associate it with the object where you want it to be executed. Drag the player object to the rigid body parameter in the visual script to get the references. There is a problem or a bug with this functionality. You will see on a lot of occasions that the reference is lost, and you will have to relink the rigid body object several times. So, let's run the game. Let's open also the Visual Script editor again, as it allows us to check on how it is running. Let's try to jump. Nothing happens and there is no message being shown in the debug window. This is because we have forgotten to set the node Get Key Down to pure node. We are not sure why this has to be done, but if you don't do it, then the input will not be read and the visual script will not work correctly. So, in the Visual Script editor, right-click on the Get Key Down node and choose the bottom option, Convert to pure node. Save and let's go back to the game. If you try to jump, you can see that the debug is showing the jump message, and if you look closely at the Visual Script Editor, every time you press the jump button the links between nodes are illuminated and animated to depict the flow of execution. So, again the lack of jump is due to the intensity of the force. Adjust the numbers of the force parameter in the Visual Script until you can see a jump happening. If you want, you can also play with the physics material to shape different behaviors for the object when jumping and landing. Time to try to fulfill another promise. Integrate a C++ script in the game. Well, let's try it. Let's create a new C++ script. You can see that FLAX creates both a C++ file and a H. Let's try to add it to the object. We can see that the object is not receiving the C++ script. Although we can script in C++ and we can access from the C++ both C# and Visual Scripts elements, C++ is more geared toward coding common elements of the game, or more precisely from a standard global framework of reference. So, if we want to use C++, we need to change the compilation mode of the full program and then recompile everything, which is out of the scope of this second tutorial, although we will look into it later on when we become somewhat more expert in the engine inner workings. Let's finish now. In the next episodes, we will certainly keep exploring the different options the engine allows while creating some basic gameplay. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.